Welcome back, students, to the third video of this playlist where we will be learning about how to combine linear inequalities. So, in the previous videos, we have seen how to solve linear inequalities and quadratic inequalities. So, in this one, we will talk about solving linear inequalities where we have more than one inequality to deal with. So when we have multiple inequalities, our task would be to solve them individually, and then we will draw a number line in order to combine our final answers from both of the inequalities and get the common answer. So this method basically works like this, where we have this one example. In this example, we are asked to find out the set of values of x for which both of these inequalities are true. So how are we going to solve it? We are going to first solve both of these individually. So we will take this one and solve it. So we are going to get 5x plus 9. This is the question. 5x plus 9 greater than x plus 20. So we will write 5x minus x is greater than 20 minus 9, which gives us 4x is greater than 11. And now when we are dividing, we know when we are dividing with a negative number, only then our sign changes. So we are not dividing with a negative number, so our sign will stay as it is, and then 11 by 4 we get in here. And for this one, we have 12 minus 3x is less than 27 given in the question. So we will get minus 3x is less than 27 minus 12. So we get minus 3x is less than 15, which gives us x is more than minus 5. The reason why the inequality changed from this part to this, the inequality changed from less than sign to the greater than sign. The reason for this is because we are dividing with a negative number. For minus 3, the sign changed. So now what we have to do is we have to combine these two answers. Now, how do we combine these inequalities? By finding the common region from the number line. So we know how to represent these in the number line. We will do that here. We will first draw the number line for x, and in this number line we will only put down the critical values, the values that we get from here. So 0 we have in here, and then we have minus 5. Now 11 by 4, if you take a look from your calculator, if you press your calculator, and in decimals it comes as 2.75. So 2.75 indicates that it is a positive number and somewhat closer to 0 compared to minus 5. So it should be here. 11 by 4 should be here. Now, if we draw these inequalities, we have x is greater than 11 by 4. So x is greater, x is more than 11 by 4. On the number line, we know the numbers on the right are greater than 11 by 4. So we will draw a circle at the critical value, and then we will draw a straight line in here that represents x is greater than 11 by 4. And also x is greater than minus 5. So we will draw a circle in here at the critical value, and we will draw a straight line on the right. The right side represents the greater side. Now, what is the common region or the overlapping region that we have? This is our common region, the region in between the two lines. This is where our inequality lies. This is where our final value of x lies. This is the region which satisfies both the inequalities. So here we will write our final answer as x is more than 11 by 4. We can see from the number line. So we will write it as x is more than 11 by 4. And this is our answer. So this is the solving technique for any combination of linear inequalities. We will try to solve both of the inequalities individually And then we will represent these answers in the number line. From the number line, we will find out the common region. When we are drawing the number line, we have to make sure that for greater than or less than sign, we represent them using an empty circle at the critical points, at the critical values of x. And for greater than or less than equals to sign, for greater than equals to or less than equals to sign, when we have an equal to attached to them, we will draw a solid circle. A solid circle is a solid circle like this, a black circle like this. So we draw a filled circle when it comes to greater than equals to or less than equals to sign. And for greater than or less than, simply we use an empty circle, a blank circle. So let's move to the next one. In the next example, we have these inequalities with greater than and equals to, less than and equals to sign. So we are going to solve these individually. So in here, we have 3 into 3, which gives us 9 plus 3 into 2, which gives us 6x is less than equals to 8x plus 2. So now we know we have to change sides. So we will write 6x minus 8x is less than equals to 2 minus 9, which gives us minus 2x is less than equals to minus 7. Now we know minus 2 is a negative number. So when we change sides, our sign also reverses. So less than equals to becomes greater than equals to. And we will have minus 7 divided by minus 2. So the negatives will get cancelled out and we will be getting 7 by 2 in the answer. In the same way, we can solve this one. So we have 2 into 2, 4x, then 2 into 3 will give you plus 6 is less than equals to x minus 4. So we get 4x minus x is less than equals to minus 4 minus 6. So we get 3x is less than equals to minus 10. So now, because we are dividing with a positive number, the sign will not get reversed and we will get x is less than equals to minus 10 by 3. Now we have to draw a number line to combine both of these answers. So how are we going to combine this? In the number line, we will first represent the number line for x. 0 is something that we always draw, and then we will put down the critical values. So if we take a look at the critical values, this is 7 by 2. 7 by 2 is 3.5, and minus 10 by 3 comes as minus 3.33. So minus 3.33 and 3.5, these two values are pretty much closer to each other, right? Both of these values are almost similar. So we will place them in here. We will give minus 10 by 3 in here and 7 by 2 in here. So now if we represent both of these inequalities, for x is greater than equals to 7 by 2, 7 by 2 is the critical value. So we draw a filled circle for 7 by 2, and then x is greater than this value. So greater means on the right side. So we draw an arrow like this. Then for x is less than equals to minus 10 by 3. Minus 10 by 3 is the critical value. And we have less than equals to sign with it. So for equals to sign, we draw a filled circle. And then x is less than this value. So less means on the left side, we draw the line. Now, are there any overlapping regions in here? No, we do not find any overlapping regions in this place. So what should we write? In this case, we have no common solution to these inequalities. There is no common solution in where both of these inequalities are true. There are no values of x in which both of these inequalities stand true. Then let's move to the next one, which is this example. So here we have 2x minus 5 is less than 7. So we can write this as 2x is less than 7 plus 5. So x is less than 7 plus 5 is 12. So 12 divided by 2 gives us 6. And here we have 9x minus 8x is greater than equals to 16 minus 71. So we get x is greater than equals to minus 55. Now representing these two in the number line, we will get a number line drawn for x. Then we have 0 in here. Now 6 is comparatively closer to the 0 rather than minus 55. So we put 6 in here and minus 55 somewhere here. So now we have an empty circle for less than sign at the critical value 6. So we give an empty circle in here and we have x is less than 6. So all values of x are less than 6. So all values of x are on the left side of 6. Then we have a critical value which is minus 55. So we give a circle at minus 55. We see that we have a greater than equals to sign. So for greater than equals to sign, we have to fill the circle and then x is greater than equals to 55. So all values of x are on the right side of this number. So they are bigger than the number. So the arrow goes to the right side. Now if we want to draw a common or overlapping region, so this is our overlapping region, the region in between the two lines. This is the common region. So the common region that we see starts at minus 55 and then ends at 6. Our value of x lies in between these 2 points. So x lies in between minus 55 and 6. Now if we take a look at the position of x, x is on the right side of minus 55. So that means that x is more than minus 55. Minus 55 is less. So we give this sign. But we see that we have a filled circle in here. So filled circle means that we will give an equal to sign also. And then if we take a look at x comparing it with 6, then x is on the left side of 6. So we know on the left side we have less values and on the right side we have greater, bigger values. So if x is on the left side of 6, then x should be smaller than 6. And at 6 we have an empty circle. So an empty circle represents no equal to sign, only the greater than or the less than sign. So this is our final answer for this one. I hope there are no questions in how we combine the linear inequalities. If there are other questions, then please write them in the comment section so that I can get back to you. See you in the next